Okay, so question 19 says that a golfer imparts a speed of 30.3 meters per second to a ball, and it travels the maximum possible distance before landing on the green. The tee and the green are at the same elevation. How much time does the ball spend in air? What is the longest hole-in-one that the golfer can make if the ball does not roll when it hits the green? So we start off by drawing our diagram. And in order for the ball to attain the maximum possible distance, it has to be directed at a 45-degree angle. The 45-degree angle gives any projectile its maximum possible distance, so we have to use it in this problem. So we have 45 degrees, and our initial velocity is 30.3. Our x component, using our cosine function, we find that the initial velocity in the x is 21.43, final velocity is 21.43, acceleration is 0, and we don't know our displacement or our time. So for our y components, using the sine function, we find that the initial velocity in the y is 21.43. We don't know our final velocity in the y, and we know our acceleration is negative 9.81. Our displacement in the y is 0 meters because we know that the ball falls back to the same elevation in which it was launched. Therefore, its displacement is 0. And we don't know the time. So in order to solve for part A, we have to find the final velocity first. The final velocity squared equals the initial velocity squared plus 2 times our acceleration times our displacement. So we plug in our y values, and we find that the final velocity in the y is negative 21.43 meters per second. Then we use that value to solve for the time, using the kinematic equation that our final velocity in the y equals to our initial velocity in the y plus our acceleration times our time. And we find that the time is equal to 4.37 seconds. Then for part B, we have to use the equation that our displacement is equal to our initial velocity times our time plus 1/2 our acceleration times our time squared. And once we plug in our values, we find that the the displacement is equal to 93.65.